Hello everyone, I am Yiwu. I am a graduate student from Hangzhou Dings University. I am delighted to share my work with you. My paper is discovering hidden interests from Twitter for multidimensional analysis. I will introduce my paper in the following four parts: introduction, mining interests, experiment, conclusion and future work. Now let's come to the introduction. Twitter is an online social networking service that enables tweeters to send and read short messages called tweets. Twitter data consists of two parts: structured data, such as ID and location, and unstructured data, such as text messages and short links. Tweeters have some social behaviors, such as follow, mention, and retweet. Online analytical processing, or OLAP, enables users to analyze multidimensional data interactively from multiple perspectives. With the explosive growth of Twitter, it has become increasingly necessary to introduce the technology of OLAP to analyze the complex Twitter data in an interactive manner. Unfortunately, although OLAP technology provides an intuitive inquiry form that is consistent with human custom, it can only handle structured data and fails to deal with scenarios related to unstructured text data, such as tweets. The issue this paper tries to resolve is how to extract the relevant information from the unstructured Twitter data to construct dimension hierarchies of Twitter's interests to achieve effective online multi-dimensional analysis. Then I will tell about mining interests. When MSLDA generates a tweet, as shown in the figure, it first chooses an interest from the multinomial distribution set sub M, which is generated by Dirichlet distribution with parameter alpha. Afterwards, it chooses a sub-interest Z apostrophe according to the degree of social impact and semantic impact. Finally, it chooses a word omega from the multinomial distribution phi apostrophe sub k apostrophe, which is generated by Dirichlet distribution with parameter beta apostrophe and gamma apostrophe. There are some characteristics of MSLDA. MSLDA is possible to identify multi-level topics hidden in large-scale data such as Twitter. MSLDA allows the semantic similarity between words and interests to affect the process of model generation in order to improve the recognition results of sub-interests. To capture the social relationship, we build a social list for each Twitter and then add this social list as an influence factor into MSLDA model. Here are some formulas used to build the model. H sub M, common K apostrophe, or the social impact, denotes the degree that the social relationship affects the Twitter M being interested in the sub-interest K apostrophe. Let gamma apostrophe sub K apostrophe comma V be the degree of word sub-interest semantic impact of the word V belonging to the sub-interest K apostrophe. Let gamma sub K comma K apostrophe be the degree of sub-interest semantic impact of the sub-interest K apostrophe belonging to the interest K. We sample all interests and sub-interests until we achieve the stable sampling results according to the following two posterior distributions. Finally, we obtain some multinomial distributions which we want to get. Following the above steps, we construct interest dimension. Firstly, we determine the relationship between sub-interests and interests according to the distribution of the interest-sub-interest probability distribution. Secondly, a word can belong to multiple sub-interests according to the distribution of sub-interest words. We choose the top 20 maximum probability words that belong to the sub-interest to be the word set of this sub-interest. Finally, we name the sub-interest according to its corresponding word set, and the interest according to the sub-interest set that belongs to it. Next, I will tell about experiment. To evaluate the effectiveness of our approach, we conducted the extensive experiments on real Twitter data collected by Twitter REST API. Firstly, we selected 15 Twitter users from the Twitter homepage as the seeds and acquired all their 7,373 followers. Next, we retrieved the Twitter's profiles, tweets, and their social relationships. Finally, we removed the tweets with fewer than 6 words and the duplicate tweets. In this way, we obtained 10,116,317 tweets from 6,907 Twitters. This table shows the statistics of the dataset. The number of tweets that contains at amounts to 62% of the total, and the average number of Twitter's followers is 1,565, indicating the rich social relationship. We randomly selected 110 Twitters from the total of 6,097. 5 postgraduate students manually labeled the sub-interests of the 110 Twitters independently. If they failed to reach the same sub-interests for a given Twitter, they simply labeled the Twitter with the majority vote. The performance of MSLDA is evaluated by 3 widely adopted metrics, namely precision, recall, and F-measure. The up table shows the average precision, denoted by P, recall, denoted by R, and F-measure, denoted by F, of MSLDA compared with those of LDA and Twitter LDA. As it indicates, our method achieves the best values. The bottom table shows the statistical significance based on p-value of MSLDA compared with those of LDA and Twitter LDA. In the case of the significance value being set to 0.1, our method outperforms the other two with regard to precision, recall, and F-measure. Unlike Twitter LDA and MSLDA considers the social relationship among Twitters and the word semantics of tweets. In order to investigate the effect of these two factors, we also conduct experiments without these factors. As figure shows, the F-measures of standard MSLDA are better than those of MSLDA which does not consider social relationship or word semantics under all circumstances. MSLDA considers the social relationship among Twitters and the word semantics of tweets. Based on the above data model, we can conduct various operations such as roll up, drill down, and dicing on Twitter data. For example, this figure shows the result when drilling down from spots, which reveals the distribution of 3 different sub-interests of spots in different areas. The data can be aggregated by rolling the area level up to the country level. Generally speaking, the interest tweets revealed are always changing, which indicates the drift by time. Because all of the Twitter's tweets are grouped according to different granularities of time periods. The trained MSLDA model can be employed to discover the drift of interest distribution of the tweets in different periods. As this figure demonstrates, in January and February, tweeters pay more attention to basketball, but in April and May, their interests are transferred to football. On the other hand, the numbers of tweeters who are concerned about movies remains almost stable from January to February in 2016. At last, I will introduce conclusion and future work. The main contributions of this paper are following. We present a new model called MSLDA for mining the dimension hierarchy of a Twitter's interests from unstructured massive Twitter data, which considers not only tweets but also the social relationships among tweeters. We take advantage of word-to-vector, a two-layer neural network model, to obtain the linguistic similarity of words to improve the effectiveness of identifying the interest dimensions. We performed the multidimensional analysis of Twitter data, which demonstrates the effectiveness of MSLDA. In the future, we will consider the use of Twitter data to train the word-to-vector model to improve the effectiveness of MSLDA. The word-to-vector model employed in this paper is trained using news provided by Google, and it spent about 2 hours running the experiment with 297,000 and 517 tweets. In the future, we plan to parallel MSLDA to finish the experiment in half an hour or less. That's all. Thank you for listening.